This video will be about limits of functions. So I want you to think about if you had a function, let's say it's an f of x, and you plugged an x value into the function, you would get a specific output value, which is our y value. So let's take a look at some of those just to refresh your memory. So let's say our function is f of x equals x squared minus 16x all over x minus 4. And I wanted to find f of 3. Remember, what you would do is you would just plug 3 into the function. So we'd get 9 minus 16 and 3 minus 4. So that would equal 7. That means that the f of x value when x is 3 is equal to 7. So our input is 3 and our output is 7. If you wanted to find f of 0, which would be the y-intercept, if you can remember that, you'd have 0 squared minus 16 over 0 minus 4, and that would give us negative 16 over negative 4, which is 4. Let's look at one more. Let's say I have f of 4. Now you might already notice that there's going to be a problem there. You would have 4 squared minus 16 over 4 minus 4, which would give us 0 over 0. And you cannot divide anything by 0, so this function is undefined at x equals 4. And that is a very important thing to know. Even though we cannot actually have a definition of x equals 4, what y equals when x equals 4, we can understand some things about the function still at x equals 4. So to do this, we're going to introduce the idea of a limit. Alright, so what is a limit? That's what you're probably thinking. So as a function approaches a specific x value, the limit of a function is what the y value approaches. Now there's a couple ways to look at this. I'm going to go look at a graph here. So if this is my a value, my limit of my function at that specific a is what the function approaches. So as we approach from this side and this side, the limit of my function a is whatever f of a is. Now you don't always have an f of a, so let's take a look at one other case here. Let's say my function comes up and approaches this way, and let's say this is my a value. My function could come up, and from both sides my function approaches infinity at a. So in that case, the limit would be infinity. Now you can also have lots of other different cases here. I've run out of room, but let's say you had a hole in your function at a. Even though you can't define the f of x value, there still will be a limit because it is what the function approaches, not exactly what it is equal to. Alright, there's a specific way that you write the limit of a function. Before you would have f of x, and that just represented the function. And if you wanted to plug an a value into the function, you could plug pretty much anything you wanted to, as long as it was defined. Now here we can actually find the limit of any function, whether it's defined or not. Okay, and so this is how you write out the limit of a function. So what that means, it says, is the limit as x approaches a of f of x, of the function. Okay, so a is the value x is approaching, and f of x is our function. So we're going to look at 3 different ways on how to find the limit of a function, and really each way depends on what you have in your function. So the first way is if there are no restrictions on your function at your x value. If the x value can be plugged directly into the function and you get a y value, the limit of the function at that x value is equal to the y value. So for example, if I had the limit as x approaches 3 of x squared minus 16 over x minus 4. So if I have this function and I can take the 3 and plug it into my function without any restrictions, then this limit as x approaches 3 can be solved by just plugging 3 in for x. And this will always work as long as you can plug your x value. So we already actually found this earlier, but just a quick recap, it was negative 7 over negative 1, which was 7. Okay, so the limit here is equal to 7. Because you can plug it directly in and there's no problems. Now you're probably wondering what happens if there is a problem. So that is the next method here. So the next method is that you can use algebra to solve the limit. And this will only work if a reduced form of f of x allows you to plug the x value in. So let's look here. If I had the limit as x approaches 4, x squared minus 16 over x minus 4. Now we saw earlier that we cannot plug 4 directly into this function. Okay, because it gives us 0 in the denominator, so we can't use our first method. But what we can do is maybe use algebra to simplify this and then plug it in. So if I take this function right here, and let's factor the top, and if the bottom could be factored, factor the bottom. Whoops, sorry. X minus 4. Then we could cancel the x minus 4's out, and what we end up with is the limit as x approaches 4 of just x plus 4. Now I can plug 4 into that function. It would just be 4 plus 4, which equals 8. So that means that this limit of this function approaches 8. It does not mean that the function equals 8 because the function is undefined at that x value. What it means is that as x gets closer and closer to 4, the f of x value gets closer and closer to 8. Now it will never actually equal 8, but that's what it approaches. All right, we're going to look at the last method here, and you can actually use the last method for this process as well if you're having trouble reducing. And it is going to be making a t-chart, so let's look at that. All right, so once again, if x cannot be plugged into the function because of a restriction, you can make a t-chart and find approaching x values to see what y approaches. So let's take a look at our last problem we just did. So we had the limit as x approaches 4, x squared minus 16 over x minus 4. All right, so what you can do, let's say I have an x and an f of x value. Our x value needs to approach 4. So that's our magic number. We are going to make values that get closer and closer to 4. Now, the more values you have, the better approximation you'll get, but it doesn't matter too much. So approaching from the left side, let's start at 3.9, then 3.99, and then 3.999. We're going to plug each of those x values into our function here and see what y value we're getting closer to. All right, let's see, the 4.1, 4.001, and 4.001. And I'm going to plug those into a calculator. You can't really do this without a calculator. So if we plug 3.9 into the function, and I just used a calculator, I would get 7.9. If we plug 3.99 into the function, we get 7.99 and 7.999. So as you can see, from the left side, From the left side approaching 4, we're approaching 8. We're getting closer and closer to 8. If we plug it in 4.1 in, we're going to get 8.1. Here we would get 8.01 and 8.001. You have to be approaching the same value from both sides, otherwise the limit doesn't exist. But as you can see, from the left side and from the right side, we're getting closer and closer to 8. So our limit will be equal to 8. Now there are some functions where you can't use algebra. You'll actually have to use this chart, and that's when the function doesn't reduce and you can't just simplify it. So let's take a look at 2 more quick problems where we use this method. Alright, so if I have the limit as x approaches 4 of x squared minus 9 over x minus 4. Now we would simplify this first and see if anything would cancel, but it doesn't. So we're going to use our chart. Our x value, and then we have an f of x value. Our x value let's put, that x value should be 4. And we're going to approach the 4 values. So let's go approach it from the left. So we'd go 3.9, 3.99, 3.999, 4.1, 4.01, 4.001. And I'm going to plug these values into the function. I will just come up with them so you don't have to worry about time of me calculating them. Alright, so I went and calculated these. I get negative, I'm just going to round to whole numbers because it's not going to matter too much with the decimals. And then let's see. Okay, so what's happening here is this is getting larger and larger negatively. So I guess we could say smaller and smaller. So this is approaching, it's going to approach negative infinity. And if you wanted to test more and more values and see that it's getting more and more negative, you could. From this side, it's getting bigger and bigger, but positive. Okay? Since those both approach 2 different sides, and they are not equal, because negative infinity is not equal to positive infinity, we actually say the limit does not exist. So to write that out in limit terms, we just write DNE. Does not exist. All right, so let's look at one more. Let's see. If I have here the limit as x approaches 0 of 1 over x squared, and I want to find that limit. Now we can't reduce it because nothing's going to cancel out. So let's do our t-chart. We have our f and our f of x value. Hopefully that's enough space. We are going to go, maybe let's start at, let's go negative 0.01, negative 0.001, and negative 0.0001. And then let's just flip that on this side. I probably started those smaller than I needed to, but that's okay. I'm going to go quickly and calculate those so you don't have to watch the calculations. Alright, so what I thought was going to happen happened. I'm not going to have enough space. This one, it was 10,000. This one was 1 million. This one was 100 million. And that is about as sloppy as you can get, sorry. This one was also 100 million. Just going to put all those zeros down there. This one was 1 million again. And this was 100. No, I was wrong. Sorry. That was 10,000. Okay. All right. So if you can see from the left side, you're getting bigger and bigger. Hopefully you can see that going from 10,000 to a million to 100 million is getting closer and closer to infinity. And from this side, you are also getting closer and closer to infinity. So the limit as x approaches 0 of 1 over x squared approaches infinity. And your solution can be infinity if that is what the limit is equal to. So that is a quick introduction of limits.